Hey guys, so today we're going to be talking about quadratic functions, but before we begin, I have a quick joke. So what do baby parabolas drink? Quadratic formula. Very cringy, I know. Let's get into it. Quadratic formulas are all around us. Like for example, the McDonald's sign, that is two concave down parabolas in itself, and that's just me, but I've never gone a day without seeing the McDonald's sign. When you're throwing a ball, for example, if you like take it in slow motion and you see how it goes, it also produces a parabola, and to that also has a maximum height, which we call the vertex. And like also some famous monuments and sightings also use the parabolic structure. So that's just cool that we see quadratic functions and parabolas outside of just our Cartesian planes in math class. So let's go into defining quadratics. A quadratic function is simply a function that takes a form of ax squared plus bx plus c, where a, b, and c are numbers that are not equal to 0. So ax squared plus bx plus c. So any function that can fit into this form, or a equation or formula that can be intertwined and translated into this form, is going to be able to produce a parabola, which is simply a graph of the quadratic function. So the example we're going to be looking at is y equals x squared minus 2x minus 3. In this case, the a is going to be 1, the b -2, and the c is -3. The line of symmetry is simply the line which cuts the parabola in half. So if you folded the parabola on its line of symmetry, both ends would perfectly line up with each other. But more specifically, the line of symmetry's equation is like an equation that can be described as the axis of the x-coordinate, or the equation is going to be the x-coordinate of the parabola itself, or the vertex of the parabola. Speaking of the vertex is simply the point where the parabola crosses its x-axis of symmetry. And it's also going to be the point in which the direction of the parabola changes. So as you can see, it keeps going down here, but once it reaches its vertex, the direction changes and it starts going upward. The x-intercepts are points on the x-axis in which the parabola passes through. So in this case, it's going to be -1 and 3. And the y-intercept is going to be the point on the y-axis which the parabola intersects. And in this case, it's -3 as well. So yeah, let's get into the forms of quadratic equations. There are 3 specific forms, and the first one is the standard form, which we've been discussing, which is y equals ax squared plus bx plus c. The next form we have is vertex form, which is y equals ax minus h squared plus k. This form is very useful, especially if you're trying to find the vertex of the graph, which can be seen from its vertex form, and it's going to be simply h and k. All right. There's also factored form, which is y equals ax minus x minus p and x minus q. This form is very useful if you're just looking at a graph and all you can see are its x-intercepts, because the p and the q represent the roots or the x-intercepts of the function and the graph itself. And throughout, we're going to be learning how to convert between each form or how to convert back, and seeing how it is in the relationships between the different forms. Also, we're going to be discussing the discriminant. The discriminant, what the heck is that, you might be asking? The discriminant is simply, if you look into the quadratic formula, what's under the radical, which is b squared minus 4ac. And you still might be confused as to why do we need that? And that is because it's an easy way to see how many solutions a function can have. So with that, if you plug in your a, b, and c into b squared minus 4ac and you see that it's less than 0, then know that you have no real solutions, meaning your solutions are probably imaginary. If you plug it in and you get that number, the discriminant is greater than 0, then you have 2 real solutions. And if you plug it in and the discriminant is exactly equal to 0, then you have 1 real solution, or otherwise known as a double root. All right, so this is practice problem number 1. It says f of x equals 6x squared minus 48, which equals negative 12x. All right, so we can see that this is in standard form, all right, because it has an a, b, and c, even though it's not in the same format. And they want us to express f of x in the form ax minus h squared plus k. This is a vertex form. Okay. So to do that, to convert from standard form to vertex form, we have to do something called completing the square. So we have to complete the square. That is simply just a routine in which you take the standard form, the a and b, and plus another number to make it into a perfect polynomial that you can square out to get the vertex form. So we'll do just that. First, we're going to add 12x to both sides to get it into ax squared plus bx plus c format. Do 6x squared plus 12x minus 48 is equal to 0. All right, so from here we can see that a and b, we're going to ignore c for a little bit. A and b are both can be factored by 6. So we'll do that. 6x squared plus 2x, and then we're going to add another number here, so we'll leave that blank, minus 48 side. This is still going to equal 0. And okay, so you may be wondering, what number are we going to add here? And to that, we're going to be adding a negative b over 2 squared. And in this case, it would be negative 2 over 2, which is negative 1, squared, which is 1. So we're going to add 1. And never in math have we ever been just able to add to something. Just add a number to one side without subtracting it another else. So that's what we're going to do. In the same parentheticals, we're going to subtract 1. That won't do us any good if we combine like terms, so our end goal will be to get that negative 1 out there. But right now it's bound by that 6 right here. So what we're going to do is we're going to multiply negative 1 by 6 and to get it free from the parenthetical, and then move it outside right here by negative 48. So let's do that. We have right here is 6x squared plus 2x plus 1, and since with the 1 we subtracted 1, multiplied by 6, we'll have negative 6, and then our usual negative 48. All right, so with that, x squared plus 2x plus 1, right here, that we made that into something that's easily factored into, and for that would just be x plus 1 squared, right? Because if you expand that out, you get x squared plus 2x plus 1 minus, and then negative 6 minus 48 is simply minus 54. And that is going to be our final answer. If you wanted the vertex from this, you could get that easily by looking at the h and k and seeing that it's negative 1, negative 54. All right, so that is going to be the vertex of this, and this right here is the answer. All right. So there's a second part to the same problem, and now this is saying to express f of x in the form f of x equals ax minus p, x minus q. Hey, we know that this is factored form. All right, so let's just rewrite f of x again, and remember f of x as, after we added 12x to both sides, was 6x squared plus 12x minus 48. All right, and now they want us to factor that out to make it into factored form. But to begin, if there's always something you can factor out all three numbers by, you should do it. Here, the easiest way is 6. So we're going to do 6x squared plus 2x minus 8. And this is still equal to 0. All right, so since we get this, we have to now factor this out. And how we're going to do that is simply by doing it. Oops. We're going to be doing it how we factor stuff out normally, by seeing what goes into what. So, all right. So we're going to be seeing what plus what equals 2 and what times what equals negative 8. From both of those, that is negative 2, 4. All right, so we can take 6, do x minus 2 and x plus 4. All right, and this is going to be our completed answer because it is now in factored form. And if we were to find the x-intercepts or the roots, you can see by using the null rule, since this is equal to 0, set both of the parentheticals equal to 0, you would get x equals 2 and x equals negative 4. All right, so this problem is a discriminant problem. To review, the discriminant is simply b squared minus 4ac. That is the discriminant. And since they said they want one solution, if we review back, that means the discriminant is going to equal 0. So since we know that, let's find the a, b, and c. Okay, the a here is k, the b 4, and the c 2. Let's plug it in. 4 squared, b squared, and then minus 4, our a, k, and then the c, which is 2, still equal to 0. Now 16 minus 4k, so negative 4 times k is negative 4k, times 2 is negative 8k, equal to 0. With that, we're going to add negative 16 to both sides. To that, we'd get negative 8k is equal to negative 16. We divide both sides by negative 8. And with that, we'd get k is equal to 2. So whenever k is equal to 2, it is going to give the function 3 plus kx plus x squared 1 solution. All right, so let's see now for your assignment if you can solve these two IB style problems. Pause the video and see if you can try it out on your own. All right, so to solve number 1a, you can simply see the values of p right here because p and q in the factored form are simply the x-intercept, and that would be negative 1/2 for p, and for q, 2. 2. It's going to be q, this will be p. All right, for b, it says the function has a minimum value at c. So c right there, since it's a minimum value, that we can concur that that is our vertex. And they want us to find the x-coordinate of c. So how we're going to do that is we're going to first put it into factored form, which they gave us. So y equals x plus 1/2 and then x minus 2. Right? So now we're going to convert or just expand and FOIL out. We'll get y equals x squared minus 3/2 x minus 1. All right, so with that, now we have the standard form and we know how to complete the square. So let's do that. And after you complete the square, you should get y equals x squared, or y equals x minus 3/4 squared minus 25/16. And since it's only asking you for the x-coordinate of the vertex, which we know is h/k is going to be h, it is going to be 3/4, is going to be the x-coordinate of C. All right, so the second problem on the assignment was simply to find the value of k, which made this discriminant or just function in general have one solution. Okay, so with that, we have to look to our discriminants again and see that to have one solution, it's going to equal 0. So to just find our A, B, and C real quick, our A is going to be 1, our B is going to be k, and our C is going to be 3. To find one solution, we're just going to do k squared minus 4, 1, 3 equals 0. And then that is k squared minus 12 equals 0. Then k squared equals 12. And then with that, you can simply square root both sides and see that k is going to be equal to plus or minus 12. So whenever k is either plus square root of 12 or negative square root of 12, it's going to give the problem 3 plus kx plus x squared 1 solution.